Welcome to my LeetCode bi-weekly contest 142 livestream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few minutes, we'll be doing the contest live, we'll be answering questions and giving hints in the chat. So come join us every weekend for the contest. No code will ever be shared while the contest is running, but after the contest ends, we'll go through answers for all 4 questions. So stick around. If you enjoy LeetCode, make sure to check out the rest of my channel. I have videos on different problems as well as the hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright, so we are live. Let me see. I see some people around. Welcome. Welcome to the channel. For those of you who are new, this is a live contest, LeetCode contest live stream. So we'll be doing the contest live on stream. The only catch is that I normally don't show code on stream while I'm working on it, while the contest is running. This is to make sure that this contest competitive integrity for people who care about these things. But if you talk in the chat, if you ask questions in the chat, I will answer you. So let's see who's around today. Normally weekly contests are a little bit quieter. Alright, so we have about 15 minutes before the contest starts. I'm going to, ask questions if you want to talk about anything in the chat. If not, I'm going to actually work on the daily problem. So I don't know about you guys, but I'm trying to get my daily problem streak up again. I lost my streak a while back when I was on hiatus. And that was very unfortunate because my streak was like 100-something days and lost it because I just missed one day and the 100-something day streak is gone. Alright, so this is today's daily problem. Binary tree post-order traversal. Given the root of a binary tree, return the post-order traversal of its node values. So always look at examples. If the input is like this, output is 3, 2, and 1. The post-order traversal of its node values. Okay, so the binary tree is, first of all, is given as a list. Is it given a list? No, it's given as actual binary tree object. So this is just an example. Okay, so it's given as binary tree object. You have to return the post-order traversal. What does post-order mean? Post-order means that you visit the children first before the parent. So 1, 2, and 3. When you get to node 1, you'll visit its children first. So this is 2. Before coming back to 1. When you add 2, you visit its children first, which is 3. So you do that before coming back to 2. So you have 3, and then come back to 2, 2, and then 2 comes back to 1. So it goes down and then comes back up. That's post-order traversal. Oh, only 1? Okay, you know what? I'm gonna draw this. I'm going to draw this. I have a new gadget, which is a stylus. So let's say you have a tree that looks like this. Okay, so post-order traversal means that you have 1, you go to 2 and 3 first. So at 1, you have 1, but you don't do 1 first. You go to 2 and 3 first. And now you have 2. Well, what do? You go to 4 and 5 first. So you do 4, 5, and then 2. So 4, 5, and then 2. Fours are leaves. And then now you have done this whole thing. And then now you do this 3 and 6. So again, at 3, you don't do 3 first, you do 6 first. So 6, 3, okay? And then finally you go back to 1. So that's post-order traversal. Okay, so how do you do this problem? How do you do this problem? You want to do post-order traversal, right? You are given the root of the tree. So what you want to do is you notice that this is actually a recursive problem. It's a recursive problem because we did 4, 5, and 2 first, so which is this triangle, and then we did 6, 3, and then this thing, and then we did 1, right? At 4, 5, and 2, this triangle, we are doing post-order traversal of this subtree again. Does that make sense? So we sort of do a post-order traversal of our children, and then we go back to the parent. So the strategy for post-order traversal is the same whether you do it for children or parent. And you basically want to do something like this. You want to do post-order traversal of its roots left. Left first, then right. I'm going to make the assumption. I'm pretty sure that's correct. Okay. And that will give you this 4, 5, and 2 subtree. And then you want to do post-order traversal of the right. And then you want to glue them together. You want to glue them together. You just do root dot val. Okay? That's all. That's all there is to it. I just spent a long time explaining what is really a very simple problem. I'm pretty sure this will work. So I just do return and do this long string. Return post-order traversal on my left, which is the subtree, and then post-order traversal on the right, and then root.val. Okay? And not only that, I need to check one more thing. If not root, so if root is none, then return empty. Let me run this, see if it works. Oh, self.root. How Python-esque. Did I spell it wrong? Oh, self dot. I never quite liked this thing about Python. This is one of the, few things about Python that I really don't like. Oh, hi, AD3301. Good morning from India. Yeah, well, good evening from America. As you can see, my room is dark. And it's night outside my window. It's 8 o'clock in India, right? Is it 8 o'clock or 9 o'clock? I don't remember. Time in India. It's 8 o'clock. Wow. Gosh. Well, mad respect for waking up early to do the contest. Yeah. I know actually a lot of people, I'm halfway through my stream, and then people will be like, oh, I'm late. Yeah, 9 out of 10 times is because they're from India, and it's 8 o'clock. It's so early there. It's so early. And they get up late. Yeah. Hey, welcome Akash Reddy. Welcome. 7:53. Yeah, well, it's another 6 minutes. Let me see if there's another another problem that I can warm up with. How are you guys doing with regards to contest ratings? I know I don't talk about that very much, but sometimes people want to know what their contest ratings are. I know there's a few people who are knights, and then there's someone who used to come to this channel who is like really highly ranked, like 2,000 plus. I'm not highly ranked myself. I can see my record for this is very spotty. This one is hard. I didn't get a chance to do it. It's actually a pretty interesting problem. This find closest palindrome, which is yesterday's problem of the day. Hey, Cosma99, welcome, welcome. I'm glad you're spending your first ever contest on LeetCode together with us. Yeah, all the best. Good luck. I will tell you, I don't know how good you are at programming or how good you are at like specifically competitive programming. I feel like I'm a pretty decent programmer or a software engineer just in general. But when I did my first LeetCode contest, I got my butt kicked, man. Because like the questions they ask is different from what you do when you're programming. So you need to think in a slightly different way. It's not a bad way, and it's not a bad skill to have in a programmer, but it can be a very different skill that a lot of people don't normally train. So basically, I gone through all of that to say, don't worry too much about your success or failure. As long as you're here, as long as you showed up, as long as you're trying, then everybody's a winner. I genuinely believe that. Palindrome is hard. Do you try it? AD 3301. I tried it for like 10 minutes, and then I got bored. Because there are many cases, right? There's the simple case where you only have to deal with half of the string, and then there's the more complex case when you can like, go over from 9999 you go to like 1000. Yeah, then that's also very tricky. Like 9999, the closest palindrome is like 10,001. Yeah, so that's another special case. There were a few special cases. They are all in the video. They are all in the like They're all in the problem description actually. Yeah, there are like 4 hints there. It's kind of intimidating. Like all the different hints will brute force. Yeah, so this part is easy, but these are the tricky ones. Like this one is tricky because you must -1 to get 99799. And then this one you add 1. So it's not that obvious. Yeah. But that's why it's a hard problem. That's how it is. All right. Yeah. So one other thing that I did, I'm just talking stuff. I'm just shooting the shit until the contest starts. If you guys haven't realized that, one thing that I did over the weekend is I bought a new stylus. So I realized that before I was drawing pictures with my mouse, and then it was not a fun experience. So now I have an actual stylus. Damn, still not good at it. I can draw better pictures now. I can write things. Let me see if I can write something here. Yeah, because a lot of times in the past I was just writing my mouse and it's always challenging. Yeah, thank you for your kind words. I'm trying to be a better teacher. I also teach Python programming. That's sort of my kind of main job. So I have to explain a lot of concepts. You guys are actually really advanced, I have to say. Okay, so 30 seconds left. Good luck, everybody. I hope you all do well for these contests. Remember, ask in the chat if you have any questions. I cannot share code, and I will not show my code online during the contests. but ask and I will give you small hints. People have said that my hints are too big, so I'm trying to give smaller hints now. So it's fair. Alright, good luck, folks. Oh, we have duplicate questions again. So question 1 and 3 are they the same? Let me see. We have part 1, part 2s. Nope, it's different. Okay. Good luck, folks. K operations on nums. If you find the maximum minimum value in nums, multiple occurrences of the minimum value, select the one that appears first. After K operations, apply. Wait, is question 1 and 3 the same? Question 1 and 3 are the same, right? They are just bigger. Just more scaled up. Interesting. So maybe you can do... I might just try question 3 directly. So question 1 and 3 are the same. If you can do question 3, you can just copy that, paste that for question 1. I don't know if it's helpful to you, but it also means that if you fail on question 3, then you're kind of screwed. I'm going to try that. I don't know if that's going to pay off for me, but I'm going to hope for the best. k and multiplier. Okay, so k is the number of times you do it, and then multiplier is the multiplier each time. All right. Q1 simple brute force. Yes, Q1 is simple brute force. So if you can do Q1 by brute force, do it first. Q3 is not brute force, but it's not that hard either, I think. Four, 5, 6, 4. Huh, damn it. Oh, Q3 is funny. Hint for B. Let me take a look at it. I haven't started B yet because I was doing C. Okay, so counts almost equal pairs 1. I should come back to the screen. Counts almost equal pairs 1. You're given an array nums consisting of positive integers. We call two integers x, y in this problem almost equal if both become equal after performing the following operation at least once, at most once. Choose either one and swap 2 digits within the chosen number. Return the number of indices I and j in nums such that nums I and nums j are almost equal. So choose any 2 digits within the chosen number and swap them. Okay, so 3 and 30 are equal. And then 2, 1 and choose either x or y and swap 2 digits within the chosen number. Oh, I see. So choose one of them and then swap the 2 digits. Okay, so basically what this question is saying, if you think about it, I would not look at these as numbers. I'll look at them as strings. And the way I look at it is you have different pairs of strings. We're going to do it the simple way first, which is brute force. We're going to get each pair of strings. And we're going to compare them to see if they are at most one character different than the other one. So in order for them to, okay, at most once. So for these two to be, first I would, you can think about defining a function called almost equal. How will you do this? How will you do an almost equal function? You look at them as strings. If you have 1, 2, 3, 4, 5, and 1, 2, 3, 5, 4, you can look at them as strings. You look at each place in turn, and then you think, are they equal or not? This is equal, this is the same. Oh, these two are not equal. Can I get these two to be equal by swapping them? So I would start by writing this function first. That would be my strategy. Write this function first, and then see what happens next. Yeah, that's my hint. So give it a try using that. Give it a try using the hint. So write a function first. Write the almost equal function first, and then apply that to every pair of strings. So see if you can write the almost equal function. Almost equal. Swap 2 digits. Yeah, the only tricky thing to think about is the leading 0. This leading 0. 3 and 3, 0 can become almost equal if you swap the digits. Hmm. Yanhua Zhang. Oh. Welcome, welcome. Yeah. Yeah, I don't know if anyone else here understands what you just write. But I don't think it looks like it's not offensive. So welcome, welcome. It's good to have you. This is normally an English speaking channel. I try to, if you want to use your own language, whether it's Chinese or Hindi in the chat, that's fine. I'm totally fine with that. But I generally speak only English so that everybody can understand. Yeah, and right now I'm working on question number 2. Keep hitting thumbs up button. Well, welcome. Thank you for your support. Yeah, you can like the stream. It's gonna help, because I found that if you like the stream while I'm streaming, YouTube will direct more people while the stream to this channel while the stream is going on. So for question 2, you need to return all pairs. Oh, you don't have to return all pairs. You just have to count how many pairs there are. Pairs of indices. Nums minus 1, Alright. Let's see. Let's take this bad boy for a spin. And let's see if the answer is correct. 2, 10, and 0. 2, 10, and 0. Alright. Welcome to everybody else to the stream. Welcome. If you're new to the stream, this is a LeetCode contest live stream, but it's kind of weird live stream because I don't show my answers on screen. This is to preserve competitive integrity. That's right. We don't want to be accused of cheating, and it's fair, right, to everybody. push. Is this Q2? This is Q2, that's right. Q3 is funny. So Q3, I thought I had a log n solution, but it turns out that even the log n solution is not fast enough. I have an n log n solution. So I thought n log n should be quite fast, but apparently not. Let me see what we can do here. So Q3 is kind of tricky. I did a heap for Q3, but apparently it's not fast enough. So maybe there's something else more clever here that can be done. Let me see. I wonder if there's some clever thing that we can do. Equals to 1. Once again, if you have any questions, you need helps or hints, just write in the chat. So for very big numbers, apparently, I can't do this. What if I did this? I wonder if this. I wonder if this works. Question 2 is tough. Yeah, question 2 is not easy. No, question 2 is not easy. So my hint for question 2 is focus on doing this thing first. So the hint for question 2 is to create a is to define an almost equal function. Once you define this almost equal function, then everything becomes much easier. Yeah, so the best way to define the almost equal function, I think, is you have two numbers x and y, right? Let's say 1, 2, 3, 4, 5, 6, and 1, 2, 3. Oops. 1, 2, 6, 4, 5, 3. So one thing you can do is you can just go down the list, find all the numbers that are different, and if there are more than 2 of them, then you're done, right? More than 2 of them you cannot swap. If there's only 1 of them, you also cannot swap. So you can only swap with the exactly 2. So you can sort of go down the list. So you can define this almost equal function. That's all the hints I can give you. This is very light hint. You can define this almost equal function, then you're pretty much most of the way there. So question 3 is very interesting. There's a very large test case where k is like 50 million, and I have no idea how to do this. So you basically have to find I just tried, right, something to a power of 50 million, and then and Python died. So I'm trying to figure out how to do this. This is very interesting. I wonder if you guys who are working in Java would have more success. Hey Tuna, how's it going? Welcome to the channel. I think this is the first time I've seen you. I am gonna ask not to. Yeah, I am gonna ask you not to how to say. Yeah, I am gonna ask you to use my channel name, which is, so my channel name is just Alex Does LeetCode. So I am gonna ask you to use my channel name here, but I do appreciate you coming. So welcome, Tuna. Question 3. Yeah, I feel like question 3 I got most of it. I got it down to log n time, which I think should be fast enough. The only thing is when k is 50 million, then even the multiplication takes too long. Even linear time is not good enough. It has a sublinear time. So maybe somebody has some mathematical formula. Yeah, so the one thing is for question 3 is the weird thing for question 3 is this. This k is 10 to the power of 9. Oops. This k is 10 to the power of 9, which is very big. And 10 to the power of 6 is pretty big too. So you basically, like, you're trying to take nums I or whatever, and then you're raising it. You're not raising it, you're multiplying by mult, the multiplier, raised to a power of k. And if this k is 10 to the power of 9, this thing doesn't even work in Python. Even Python will crash. So clearly there must be some mathematical formula that I don't know about that will allow you to find the remainder of something times. Yeah. Can I do the remainder of this? Yeah, there's some mathematical trick here. Yeah, so you can take the mod. So that's what I did. I did a heap. It got me down to log n time. So I think it's fast enough. Heap or priority queue, right? Is sort of different names for the same thing. I'm pretty sure the answer is mostly heap, but the last part, if you write out the heap, you'll find that the numbers at some point, the numbers get so large. Like this 10 to the power 9 is huge. Just doing the multiplication will kill the compiler. Like Python will not even let me do, take something in 10 to the power 9. Yeah. So question 2, let me go over question 2 again real quick. So once again, for those who are new to the chat, we don't give answer. Yeah, most of you use C++. Does C++ work? If C++ work, oh my god, that's so much better. Python just doesn't work for that such big numbers. Actually, C++ doesn't work also, if you think about it, because C++ will cause an overflow right away. So you need to do something very clever to make the C++ work. Yeah. Anyway, are you talking about problems? Let's go over problem 2 first. So problem 2, yeah, actually there's nothing to go about problem 2. Problem 2, you need to define a function called almost equal that takes two things. And then you must check if they return true if they are almost equal and return false if they're not. So how do you do that? You just put the two things, you pretend they're strings. Right? You don't think of them as integers. So oops. So pretend they're strings. You just work with them as if they're strings. Don't think of them as integers first. But if one is longer than the other, you just add a bunch of zeros in front. Yeah. And if you have strings, how do you find if two strings are almost equal? You go down, right? And you count how many characters are different. If all the characters are same, then they are equal. If there are two characters different, then you sort of see if you can swap. I'm going to leave the specifics to you. Figure out yourself. Good luck. Question 3 is probably well, I'm really liking my new stylus. Question 3 is probably a heap or priority queue. But there's something else there to question 3 that I'm also not getting. You need a way to deal with big numbers. Yeah, I might take a look at question 4 first. I wonder if question 4... Yeah. Question 3, if you can get the heap / priority queue, should be pretty good. That's where I'm at. I might give up on question 3 and work on question 4 first. Question 4 is interesting. It looks like a bit like question 2, but not really. How to handle the case of 330 in question 2. Okay, so question 2. For 330, you just need to add zeros in front. Yeah. If they're not same length, add 0. Yeah, so code dude, I'm the same place as you. It's yeah. Basically, if you if you take that very large exponential, it's gonna cause problems. So you need to get the remainder without actually taking the exponential. So that I don't know how to do. I feel like there's a trick to it. I might come back to it because I feel like that's the only thing I'm missing. Yeah. So question 4 is interesting. Almost equal. So you can swap 4 digits. Swap 4 digits. So if Damn, this week's problems are hard. 2 sevens. Normally it's 3, 4, 5, 6. Yeah, so Om Bagel, sorry we don't give solutions, but try it out yourself. I think question 2 is not super hard. If you can define this almost equal function, you take two numbers and you want to check if they are almost equal. How do you do that? You just check if they're same length, then you go digit by digit. If they're different length, then you add zeros in front until they're the same length. And you go digit by digit, count how many times two digits are different. So icky. Question 4 is also difficult. I need the way to find the remainder after multiply something by... Okay, let me see. What's the remainder? Hmm. I don't know how to handle the 3 and oh wait, question 2, 3 and 30. Yeah, that's fine. So I don't know. So question 2, 3 and 30, you have to add zeros. So think of the numbers as strings. Don't think of them as numbers. If they are the different length, you have to add 0 in front until they are the same length. So question 2 hint is basically on the board. Define a function called almost equal. I can't give you the actual code, but basically first step is you have to make them the same length. If they're different length, you just add zeros until the same length. And then after that, you go through digit by digit. You go through digit by digit until you get something that matches. You count how many differences there are. Okay, I'm going to focus my energy on trying to do question 3. Yeah, use stoi function for 3. And yeah. Wait, stoi? Oh, interesting. I don't know if that's... Yeah, I don't know if you can do that, cool dude. Maybe you can, I'm not sure. But I would rather pad the 3 with zeros. Because it doesn't have to be 3 and 30, right? It could be something like 1, 2, 3, 4, 5, 0, and 1, 2, 3, 4, 5. Yeah, you can fill the nums with zeros in front. Yeah, exactly that. So I hope that was helpful enough. I mean, I can't... We can't give out code here. We don't write out the code here. So 3, I don't know. So question 3 is tricky. I still cannot get question 3 either. So if you feel bad about it, don't. So the heap priority queue works. It gives you 500 out of 700 correct answers, but the last few are the tricky ones. I don't have answer for 3. So for 3, the hint is use, I'm doing this with heap for 3. So I'm doing a heap / priority queue, whatever you call it, but it has a problem. This 10 to the power 9 is too big. So multiplying something 10 to the power 9 times is going to fail. And that's the part I haven't figured out. Yet. I'm trying to figure it out. Yeah, this is tricky. Just take the absolute difference, yeah. Just find which one is shorter and then add zeros to the one that's shorter. That's the way to do it for question 2. I'm still working on question C. I wonder if anybody has managed to do question 3. I feel like there's a mathematical trick here that I'm not getting. There's some mathematical trick. Because there's no way to do this. This mathematical like formula is. There's no way to do this. There's no way. Yeah. So Yen Hua Zhang, I hope you're doing well. I hope you're trying out the contest. If you have any questions, let me know. Same with Tuna. It's good to see you again, Tuna. If you're still around, if you're trying the contest, definitely let me know. Or if you have any problems, you have any you're stuck somewhere, let me know. And just that, and that goes for everybody else. Let me know how I can help. Okay, so I managed to get through test case 502, and then I can't do 503. God. Jesus. This is not easy, man. Lucifer, which one do you need hints for? Hint for third question. Hint for hi, I'm here, Hussein. Hint for third question is use a heap priority queue, but there's something else there that needs to be done beyond that, and that's the part I don't know either. How many times are divided and still? Oh, interesting. Times number of times. Yeah, so x final equals x initial times multiplier to power of number of times. So the problem is that I wonder if it's just a Python specific problem. When I just do this formula, it just doesn't work for me. The number is too big. Yeah. X initial times x times multiplier to power of num times. Yeah. Pretty much. But I mean, for the big numbers, it doesn't seem to work. But C++ should overflow, right? This should overflow in C++. I wonder how it works. Dang it. You use Java? Does it work in Java? The minimum can change. You cannot use the batch operation. Yeah, so Aditya, Raj, which question are you looking for? We don't give out answers on stream, but we will give you hints. So if you tell me which question you need help with, I can help you. I'm kind of stumped. So for those who need help for question 2, once again, I'll just show you on stage. The main idea is you want to define some kind of almost equal. You want to define a function called almost equal, some kind of function, and then that function takes 2 numbers and check if they're almost equal. So the way to add is, people have talked about this in the chat already, check they're same length, they're not same length, add zeros in front. Otherwise, just compare digit by digit, count how many digits are different and whether you can get them by swapping. So we don't give code here, Aditya. For the third problem, I pretty sure it uses some kind of heap or priority queue. But the multiplication is the hard part. That one I haven't figured out yet. So good luck. Yeah, but we don't give out answers here, and it's good that nobody is trying to share answers. Sometimes people do that. But the thing about LeetCode is if you give your answer, somebody is going to copy it exactly, and then you both get banned, right? So I'm not going to give out any of my answers. Power a multiplier? Yeah, you can use the power multiplier. But the thing is, you don't know how many times you have to multiply. That's the thing. Yeah, you can use priority queue. Yes, that's correct. And even if you know how many times to multiply, it's not. Yeah, I don't know. So don't share code on this channel. Don't share code on this channel. In Java, question 3, 503 out of 692. I'm also 503 out of 692. Yeah, so Sam, I'm in the same place as you. But for Python, I have to do something clever. Yeah, Ayush, I'm gonna ask you not to ask for code. Sorry. Yeah, I don't know what's so I can tell what I did for reducing the k. So the way I reduce the k is to if I want to take nums I times mount k, and k is very big, what I do is I do mount to a power of something like, let's say, 10. Times k over 10. So this way k is much smaller. Yeah, so this is what I did. This is my trick. But this trick is not enough. It doesn't work. Yeah, basically it doesn't work. That's the annoying thing. Yeah, so I guess the disappointing answer is I don't know what the answer is either. There's some trick to it. There's some trick. Mine also 50, so I'm at 503. 503 out of 692. Yeah, this K is definitely diabolical, cool dude. That is a very good word. I like that word. Yeah. Sorry to give you hope, the Hades. Yeah, so the trick works for 502. It doesn't work for the rest. So I don't know. I feel like there's a way to figure out how many times you want to do the multiplier. Let me try something. I think I have a plan. I have an idea. I feel like I have a new. Yeah, everybody is stuck. Ugh. I didn't try question 4. Sorry. Siddharth, yes, today was a very hard contest. It was hard. Oh my god. I have a plan for question 3. I'm doing my plan for question 3, but it doesn't seem to be correct. Ah, I have a plan for question 2. Sorry, question 3. But I don't think it's correct. Ah, damn it. All right. So the contest is over. Ah, damn it. Well, while I have everybody here, I do appreciate if people just give me a like on the stream. If you're so inclined, if you reply, if you like add a comment to the video, that actually helps me out a lot. Once again, if you enjoy my work, like and subscribe. This way you stay up to date on next time I stream, as well as any new videos that I'm going to put out. I'm planning to add a video about dynamic programming next time. Once I get around to it, hopefully there'll be next week or a couple weeks from now. Yeah. Otherwise, I hope everybody had a nice contest. This contest was difficult. I'm not gonna lie. Right? So don't be too hard on yourself if you didn't manage to do it. If you stayed until the end, you've already succeeded. You're already a winner. So appreciate all of you for sticking around. I will go through. I'm gonna take a water break, and I'm gonna go through all the answers for the 2 questions that I did manage to solve. The last question, third question, I think I'm close. I have a plan, but I don't know if it's correct. So I'm gonna talk about power sum is done by ninth rank. I'm going to talk about what my thought process was, but before that, let me just get a swig of water. H2O. Remember, guys, hydrate. Drink lots of water, it's good for your health. I'll be right back. All right. This contest is really hard. But you know, it is what it is. Sometimes things are easy, sometimes things are hard. Also, my cat is here, so maybe you can hear it meowing in the background. All right, let me just do my usual scripts for the LeetCode, for the YouTube algorithm. We are discussing solutions for LeetCode bi-weekly contest 142. Jump to specific questions using the timestamps in the video description. Please check out the rest of my channel. If you enjoy LeetCode content, like and subscribe to stay up to date on new videos. If you've not done it already, please like and subscribe. It helps me out tremendously. The more people like and subscribe, the more people come and interact with my videos, the more YouTube is likely to promote it on their search. Otherwise, I just get buried in the annals of time and forgotten. Okay. Alright, we're going to start quickly. The first question is final. So question 1. Final array state after k multiplication operations. You are given an integer nums, an integer k, and an integer multiplier. You need to... And an integer multiplier. You need to perform k operations on nums. In each operation, find the minimum value x in nums. If there are multiple occurrences of the minimum value, select the one that appears first. Replace the selected minimum value with x times multiplier. And then after that, return the final state. So how does it look like? I think this is a very, very helpful picture. You have 2, 1, 3, 4, 6, right? This is the beginning. K is 5 and multiplier is 2. So you have to do 5 times. And then each time you find the smallest, and then you multiply by 2. So at the beginning, 1 is the smallest. 1 is the smallest. So you multiply that by 2, you get 2. Second step, now 2 is the smallest. This guy right here. You multiply that, you get 4. In the third step, now you can see 3 is the... 2 is... Now this other 2 becomes smallest, right? So now you multiply that, you become 4. And then the next step, the fourth step, you multiply 3 times 2. Give me a second. Yeah. And then finally you multiply this 4 times 2, which gives you 8. You notice a few things. One is you don't know which the smallest is, and secondly, every time you search for the smallest, secondly, there are some numbers that never change. There's some numbers that are really big at the back. They never get multiplied. Okay, so how do you do this? There's a brute force algorithm where you just repeat 5 times, and each time you find the smallest, and then you multiply that, right? So there's a easy way. There's actually an easy way to improve on the brute force. And the easy way is to use a heap. Okay? For as a quick refresher, a heap is basically a data structure that tells you what the biggest items are. So in a heap, you'll store something like 2, 3, 2, 5, 6. And then what happens at each time is you'll pop the highest element, you'll shift things around, and then you can insert, maybe this is not the best representation of heap. So something like 2, 3, 2, 2, 3, 5, 6. So a heap keeps the thing not sorted, but it keeps the largest element in front. So the smallest element in front. So you pop the first one, you see this 2, you get rid of it, and you replace it by 4. And then now 2 is in front. Now you can pop the first one, you replace it by 4 again, and then you pop the next one. 3 times 2 is 6, so you replace it by 6. And then 4 times 4 is 8. You always get the smallest one, and you multiply it by 2. Right? So the heap, the magic of the heap is that it always tells you what the smallest element is, and can do it in basically log n time. So it's very fast. The insertion is in log n, and the popping is actually in O1 time. So this is much faster than if you have to search through the whole list each time, which is ON operation. So adding heap to the algorithm is a fairly straightforward process. It's just drop and replace. So basically, there's a few things that you need to take care of. One is because the heap doesn't keep track of where each element is, it shuffles things around, right? So in addition to storing the value, you also need to store its original index. So instead of storing, like just now I had like 2, 2, 3, 5, 6. At some point, I just turn this 3 into a 6, right? Another 6. I turn this 2 into a 4. So that gets confusing. So instead of storing just the numbers, I need to store the numbers plus their indexes. You need to store both the numbers and indexes. That's what I'm trying to do here. I'm going to go through all of numbers. I'm going to store the value, which is the number. I'm going to store its index. So this way I have both the number and index. And I'm going to have this as a pair. The next thing I do is for I in range k, so I repeat k times, I pop the smallest item from this heap. So smallest value. And if they're the same value, is the tie broken by index, which is very convenient. And then I heap push it back. So what that looks like is basically, the reason why I'm spending so much time here is this is actually the same answer for question 3. So what it looks like is, at the beginning I have something like 2, 0, 2, 1, 3, 2. So this is the value, and this is the index. So 5, 3, and 6, 4. And then when I pop them, when I push them, this becomes 4, 0. So notice how the index stays the same. Because the index stays the same, I know where to put it at the end. This is going to be important later. So my final output for here is going to look something like this. 8. My final output when I use a heap is going to look something like this. 4, and this 4 actually came from 1. 5, which came from 3. So this is the value, and this is the index. I have 6, which came from 2. So this 6 was actually originally 3. It got doubled and it became 6. So notice the value changes, but index stays the same. And then 6, which is the 1, 2, 3, 4, which is the original 6 over here. This 6 is the original 6. And then I have 8, which was originally 0. Okay, this will be what my heap looks like once I've run all the 4 operations, where I run k operations at the end. And so since my heap is like that, I'm now able, cool, I can replace. I can now put these things back in order. I can just go, let's say this is my result. I see 4 is at index 1, so I put 4 into index 1. 5 is at index 3, 0, 1, 2, 3. I put 5 in index 3. 6 is at index 2, 0, 1, 2. 6 index 4, 6. And then 8 at index 0. So this is the basic idea around using a heap. There's a few concepts here. One is you need to understand what a heap does, and the fact that it's much faster for finding the smallest object in the heap compared to finding the smallest object in a list. Especially the data keeps getting updated. The heap is perfect for this problem. The second trick you need to know is you need to store the index along with the heap. So this index allows you to recreate the original array again. Because when you put things in a heap, you have the values, you update the values, and you're like, okay, where did this value come from? I forgot. So having the index alongside the value allows you to put the value back into where it belongs. Okay, so this is what's happening for this problem. So this is a very long-winded explanation for question 1, because this is also the explanation for question 3. This is also explanation of question 3. So this is the part where I put things back. Alright, if you run this should be probably a very fast way of doing question 1. It's also a little bit overkill. Okay, so next I'm going to look at question 3. Because question 3 is just the same as question 1, but it has... Go to question 2. Alright, I'll be quick for question 3. So question 3 is basically the same thing as question 1. You use a heap. Now, the only problem with question 3 is that the numbers are extremely large. I'll give you an example. Yeah, I don't have the example anymore. But the answer is the questions are extremely large. Yeah, so the example is something like this. Or even this one. This is a great example. So nums is this, k is this, and mult is this. Right, so in question 1, we keep multiplying things. But in question 3, if you had to multiply something by a multiplier 56 million times, you are going to get time limit exceeded. This is just simply not going to work. This number is too big. So this is the part that I think is tripping a lot of people up. I don't know what the correct strategy is. I'm also at 502 out of 692. But the PQ, the priority queue or heap, is the right way to go. Okay, so question 2. So question 2, count almost equal pairs 1. You are given an array nums consisting of positive integers. We call two integers x and y almost equal if both integers can become equal by performing the following operations at least one. Choose one of them and swap 2 digits within the chosen number. So if you can take 2 numbers, you pick one of them and swap 2 digits, and you get the other number, then these 2 numbers are almost equal. Okay, it's important is you can allow an integer to have leading zeros after performing an operation. So example is here. 3, 12, 30, 17, 21. So the 2 almost equals are 12 and 21. 12 and 21. Because you swap these 2 numbers, you get this one. And 3 and 30. The reason why 3 and 30 are equal is because if you swap 30, you get 0, 3. And 0, 3 is the same as 3. It allows leading zeros. This part is quite important. Okay, so how do you do this problem? The most challenging part about this problem is to define an almost equal function. Once you have your almost equal function, the rest is very easy. It's very easy. So how do you define almost equal function? You want to have a function which takes 2 integers and you want to determine if they are almost equal. How do you do that? The first step is you want to turn them into a string. So for instance, if your numbers are 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, okay. 1, 2, 6, 4, 5, 3. Okay? The first thing is turn them into strings. You don't want to work with numbers. In Python, you use str. In C, you just use stoi. The next step is you want to go through this. You want to go through this. You want to go through x and y. And you want to find the parts where they are different. So this is different. This is different. If there are more than 2 differences, 2 digits that are different, then you're done. You'll never be able to swap them. Or if there's 1 digit different, it's also done. You need exactly 2 digits different or no difference at all. If there are 2 digits that are different, then you want to see if you can swap them around. So for instance, x's 0, 1, 2, 3, 4, 5. 2 and 5 are the same, the different from y's 2 and 5. Index 2 and index 5. So you want to see if they can swap them around, right? So you check if x2 is equal to x5, y5, y2 is equal to x5. If they are, that means you can swap them around and you should be good. So that's the basic strategy. And this is basically what I did here. This is basically what I did here. The first step is to turn them into strings. And then once you do strings, there's one little trick where I add leading zeros. And then what I do is I go down the list, right? I in range length of A. If they are not the same, I add them to diffs. If the number of diffs is more than 2, then I'm done. It's false. If the number of diffs is 0, it's true. If it's 1, it's also false. If it's exactly 2, then you see if you can swap. You can get these to be identical by swapping them. So this is the logic here. First, you collect all the differences. You collect like this 3 and this 6, 6, 3. And then you use some logic to figure out if they can become almost equal based on how many differences there are. So I collect all the indexes where there's a difference between x and y. Now, what happens if x and y are of different lengths? So for instance, if x is 1, 2, 3, 4, and y is 1, 2, 3, 4, 0. Wait, hold on. Sorry. That's not right. That's not right. Okay. What if x and y have different length? Well, all you have to do is to pad them to add a 0 in front. So you add a fixed 0 in front here. And after you added the fixed 0 in front, you do the same thing. This and this are different. This and this are different. Can they swap? Yes, they can swap. This is again almost equal. Yeah? So that's what this part of the code is doing. That's what this part of the code is doing. If length of A is smaller than B, then you add a bunch of zeros to A. If length of B is smaller than A, you add a bunch of zeros to B. So that's all there is to it for question number 2. Let me check if there are any questions in the YouTube channel. You use 3 and 30? Yeah. 3 and 30, you just add a 0 in front of 3. First step, you turn them into strings, right? You compare the length of the 2 strings. So you can see that 30 is length 2, 3 is only length 1. So you add a 0 in front of 3. So 3 becomes 0, 3. So this 3 and 30, this 3 becomes 0, 3. And this becomes 3, 0. So this way you can compare them. You have to have them the same length in order to compare. Let me see if there are any other questions. So I went through question 3 already as part of question 1. Unfortunately, I didn't manage to do question 4 at all, which is not great, but you know, it is what it is. Today is pretty hard. I think those of you who have followed me for a while will know I've taken a break for a month. So I'm still trying to get back into the swing of things. But I hope that you guys can be more consistent and come back week after week. I will be more consistent. I will not skip any other contest until the end of the year. That's the promise I give myself. So I hope to see all you guys here again next week. Remember, keep coding. The more you practice, the better you get, and eventually you will be able to do this really well. If no other questions, can you only solve 1 and 2? I only solve 1 and 2. That's correct. That's correct, Suresh. Yeah. Sorry about that. Yeah, it happens. I closed for 3 though. I'm gonna try and solve 3 again on my own. If I do, I'll put a YouTube video about it. Otherwise, I hope to see everybody next week. Next week will be bi-weekly contests. And yeah, that's all for the channel. Thanks for staying. My approach for question 2 is... Okay, so somebody has a question. My approach for 2 question is... Let me see if Suresh is able to ask his question. Oh, I don't see him coming back. Alright, bye Aviral. Bye folks. I'll see you next time. Yeah, you're not gonna be able to paste the whole thing here. You can try the YouTube comment. So if you go to the streaming video after it's done and put the comment there, I'll be able to have a better time going over it. Because reading code during live stream that is inside a badly formatted comment is tricky. Well, thanks a lot. See all of you next time.